All right, strap in, everyone, because today
This is going to be a good one.
we are going deep on Tendermint consensus.
That's right.
And we're really lucky to have this fantastic source material to guide us.
Couldn't have picked a better one.
Which is Ethan Buchman's 2016 master's thesis.
Oh, a clack.
Called Tendermint, Byzantine Fault Tolerance in the Age of Blockchains.
Laying the groundwork.
So this is going to be a treat for anyone who's interested in blockchain tech.
For sure.
Distributed systems, or even like the future of digital trust and all that.
Big implications, for sure.
So,
you know what I find really fascinating about this thesis?
What's that?
Is that Buchman, he really lays out this vision for Tendermint as something bigger than just blockchain, right?
So we're not just talking about cryptocurrency here.
No, not at all.
Okay, so paint a picture for us.
Yeah.
What else could we be talking about?
Okay, so think about any system, right, where you need a bunch of computers to agree on a shared history.
Like a shared record of events or something?
Exactly, like a distributed, tamper-proof ledger.
Okay, I'm starting to see where this is going.
And Tendermint, it comes in and ensures that everyone stays in sync, right? Even if some of these computers start acting up.
Oh, so there's like...
Or even try to,
some distrust built in. Or
yeah.
Like we're assuming some of these computers might be malicious.
Exactly. That's where the Byzantine Fault Tolerance comes in.
Right, because we talked about that before.
Gosh, right.
On the show.
And Buchman, he uses that classic analogy. The Byzantine general problem.
Right, with the...
trying to coordinate an attack.
Yeah.
And some of them might be traitors.
Right, exactly.
But what's really key here is the level of fault tolerance that Tendermint offers.
So how much can they handle?
It can handle up to 1/3 of its validators being Byzantine.
Okay, so that's a pretty big chunk.
It is. It's a high bar to reach consensus.
So how does it actually do that?
Well, it's a multi-layered approach.
Yeah.
First, you've got this two-step voting process with the pre-commit phases.
Right. So there's like...
And this lets validators signal their intent without immediately locking in their decision.
So they can kind of test the waters before they fully commit.
It's a buffer against any manipulation.
Okay, but at some point, they do have to lock in, right?
Right, and that locking is crucial.
Why is that so important?
Because it ensures that a validator can't just change their vote after they've pre-committed to a block.
Okay, so that would obviously cause problems.
Oh, absolutely.
Yeah.
Imagine if someone could just double sign or flop their vote.
Chaos.
It would throw the whole system into chaos.
Yeah.
It'd be a mess.
So locking is like this digital safety net.
It is.
Preventing any funny business.
Exactly.
But I'm thinking, if everyone has to agree, wouldn't things grind to a halt?
That's a good question.
If there's disagreement.
It is, but that's where the design of rounds comes in. So if a consensus isn't reached in a given round, the system moves to the next.
Okay.
With a different proposal.
So it keeps things moving even if there are disagreements.
It keeps things moving.
Or like temporary network issues or something.
Exactly.
So it's kind of like a structured debate.
It is.
Where everyone gets a chance to speak their mind.
Right.
But there's a mechanism to prevent endless bickering.
Exactly. And there are timeouts, too, to prevent any single validator from holding things up.
Right.
But beyond these core mechanisms, one of the most interesting things about Tendermint is its use of a blockchain.
So we're not just talking about the consensus protocol.
No.
It's also about how that consensus is recorded and maintained.
Exactly.
So why use a blockchain specifically?
Two main reasons.
Okay, lay them on me.
Bandwidth optimization.
Okay.
And integrity optimization.
So explain those a little bit.
So grouping transactions into blocks makes communication more efficient, especially in a distributed network.
Right.
And then linking those blocks with cryptographic hashes creates this tamper-proof, immutable record.
So it's like a digital notary, almost meticulously documenting every agreement, making it practically impossible to cheat or rewrite history.
Exactly.
Okay, so we're talking about integrity.
Yeah.
We have to talk about accountability.
That's right.
What happens if someone does try to game the system?
That's where Tendermint really sets itself apart from other BFT systems.
In what way?
It's not just about tolerating Byzantine behavior. It's about identifying those bad actors and holding them accountable.
So there are consequences for bad behavior.
Exactly. It's a level of transparency and security that you don't often see.
So it's not just innocent until proven guilty.
Right.
It's more like, we're going to know if you misbehave.
Exactly.
And there will be consequences.
That's right.
That's pretty powerful.
It is.
So what are the implications of that?
Well, it changes the game in terms of trust.
Okay.
Because traditional systems, they often rely on centralized authorities to enforce rules and punish bad actors.
Right.
But with Tendermint, that enforcement is built into the protocol itself.
Wow.
It's a fundamental shift towards a more decentralized and trustless model.
Interesting.
So you don't need those central authorities
right.
to maintain trust.
Okay, so we've got this decentralized system.
Yeah.
But it still needs a way to manage itself, right?
Absolutely.
Like, how do you handle software updates?
That's a good question.
But changes to the validator set.
Yeah.
Without everything falling apart.
Well, that's where things get even more interesting.
Okay, I'm intrigued.
Buchman introduces this concept of government.
Government,
yeah.
Okay.
It's a TMSP module designed to manage the evolution of a Tendermint-based system.
All right, so unpack that a little bit for me.
So it's like having a set of self-governing rules that the system can use to adapt and evolve over time.
So government sounds like a whole other rabbit hole to explore.
Definitely.
But before we go there, I want to touch on something you mentioned earlier.
Yeah.
Which was TMSP.
Oh, the Tendermint Socket Protocol.
Right, yeah.
Yes.
So what's the significance of that?
Well, TMSP is the bridge between the Tendermint consensus engine and the real-world applications built on top of it.
So it's how those applications actually interact with the engine.
Exactly. It's a standardized interface that allows developers to interact with the engine regardless of what programming language they're using.
So it's kind of like a universal translator.
It is. It's a good way to put it.
For all these different coding dialects.
Exactly.
But TMSP, it goes beyond just language compatibility, right?
It does.
Does it?
It also enables a crucial separation between agreement, which is the consensus part, and execution, which is what the application actually does.
So why is that separation so important?
Because it simplifies development. And it enhances fault tolerance.
In what way?
So application developers can focus solely on their app logic without having to worry about the complexities of Byzantine fault tolerance.
Right.
And if an application crashes or encounters an error, it doesn't affect the underlying consensus.
So it's like having a dedicated stage crew.
He is.
Handling all the technical aspects of performance. Allowing the actors to just focus on delivering a great show.
Exactly. And to make sure that only valid transactions make it onto the stage, so to speak. TMSP incorporates a mechanism called check-TX.
Okay, so what's so special about check-TX?
Think of it as a gatekeeper for transactions. Before transactions even considered for inclusion in a block, the application can use check-TX to verify its validity.
So it's like having a bouncer at the door.
It is.
Making sure everyone who enters meets the requirements. I'm sensing a theme here. Tendermint seems to be all about checks and balances.
It is at every level.
At every level.
It's about creating a system that is robust, secure, and ultimately trustworthy.
Even in the face of adversity.
Exactly.
Wow. Okay, we've covered a lot of ground here.
We have.
From Byzantine fault tolerance to blockchains and government. I feel like we've finally scratched the surface of what Tendermint has to offer.
Definitely.
It's a lot to take in.
It is.
But it's fascinating stuff.
It is.
So
we've laid a solid foundation. But there's much more to explore.
Okay, so where do we go from here?
Then next, I think we should dive into the real-world performance of Tendermint.
Okay, so like, how does this actually play out?
Exactly.
In real-world scenarios?
And how it stacks up against other consensus algorithms.
All right, so let's get into the nitty-gritty.
Let's do it.
Of how Tendermint performs in practice.
Absolutely.
Okay, so we've talked a lot about the theory behind Tendermint.
Right, the concepts.
But let's get down to brass tacks here. How does it actually perform in the real world?
Well, that's one of the things that's really exciting about Tendermint.
Okay.
It's designed for speed and efficiency.
Okay, so like how fast are we talking?
We're talking thousands of transactions per second.
Wow. Okay, so that's significantly faster than something like Bitcoin, right?
Absolutely.
Because we all know that Bitcoin's proof of work is notoriously slow.
Yes, and energy intensive.
Right, exactly.
Tendermint's approach is much more streamlined.
Okay.
So you get faster block times and a higher throughput.
It's like comparing a horse and buggy to a high-speed train.
Exactly.
They can both get you where you need to go.
Yeah.
But one is clearly built for the modern age.
Exactly. And it's not just about raw speed either.
Okay, so what else is there?
Tendermint also scales well as the number of validators increases.
So it can handle the big leagues.
It can. It can handle large, decentralized networks.
Okay, that's impressive.
But speed isn't everything, right?
Right. What about reliability?
That's important, too.
How does Tendermint handle, like, network disruptions or node failures?
That's another area where Tendermint really shines. Remember those Byzantine faults we talked about?
Right, the malicious actors.
Exactly.
Okay.
Well, Tendermint is built to withstand not only that malicious behavior, but also a variety of technical hiccups.
So it's like a seasoned performer.
Yes.
Who can handle any kind of stage mishap.
Right.
Whether it's a broken microphone or a power outage.
Exactly. Buchman's thesis details all these rigorous tests under these different adversarial conditions.
So they really put it through the ringer.
They did, and it demonstrates Tendermint's robustness to network delays, crash nodes, even those Byzantine actors trying to disrupt the show.
Okay, so it sounds like it can handle just about anything.
It can handle a lot.
You throw at it.
But let's take a step back for a second.
Okay.
And compare Tendermint to other consensus algorithms out there.
Right, so like Paxos, Raft, PBFT.
Exactly.
All those other approaches.
Yeah, how does it relate to those?
Right, because they're all trying to solve this fundamental problem of reaching agreement among a bunch of nodes.
Right, but they take different paths to get there.
So it's like choosing the right dance style.
I like that.
For the occasion.
Yeah.
A waltz might work for a formal ball.
Right.
But you need something more robust for a mosh pit.
That's a great analogy.
So Tendermint is like the mosh pit dance.
Well, Tendermint, like PBFT, is designed for Byzantine fault tolerance.
Right, so it can handle those malicious actors.
Exactly, whereas Paxos and Raft, they're typically used in systems where Byzantine faults aren't a primary concern.
So they're built for different levels of trust.
Precisely.
Okay, that makes sense.
And within the realm of BFT algorithms, Tendermint really distinguishes itself through its simplicity, efficiency, and focus on accountability.
Right, we talked about that. So it's like this blend of elegance, speed, and a commitment to keeping everyone honest.
Exactly.
And those qualities make it a good choice for all sorts of applications, especially as distributed systems become more and more common.
Absolutely.
Okay, so speaking of applications, let's shift gears and talk about the client experience.
Okay.
Because what good is a brilliant consensus engine
if
it's a pain to actually use?
You're absolutely right. The client's perspective is crucial.
So how does Tendermint make life easier for the people who are interacting with these systems?
Well, first and foremost, Tendermint prioritizes user-friendliness.
Okay, so that's a good start.
It provides simple and intuitive interfaces for things like network discovery and transaction broadcasting.
So it's not like trying to decipher ancient hieroglyphics.
No, not at all.
To send a transaction.
Clients can easily connect to the network and submit their transactions.
That's good news for people like me who aren't cryptography wizards.
Exactly, but what about things like network delays or message loss?
Right, because those are inevitable.
They are in any distributed system.
Yeah.
But Tendermint is designed with those challenges in mind.
Okay.
It uses mechanisms like at least once semantics.
Okay, and what does that mean?
It ensures that transactions are eventually delivered, even if they face some hiccups along the way.
So it's like having a persistent messenger pigeon.
It is.
That keeps knocking on the door.
Yeah.
Until the message gets through.
Exactly. And to handle those high transaction volumes, Tendermint utilizes transaction batching.
Right, we talked about that.
We did, grouping transactions into blocks.
So it's like having a well-organized queue.
It is.
Making sure that every transaction gets its turn.
Exactly.
Okay, but what about those impatient clients?
Yeah.
Who want instant feedback?
That's a great question.
How does Tendermint handle that need for real-time confirmation?
Well, it leverages its fast block times.
Okay.
And a mechanism called optimistic execution.
Okay.
To provide those provisional results to the client.
So it's like getting a sneak peek.
It is.
At the finished product before it's officially released.
Exactly. You get a sense of what's to come without having to wait for the full confirmation.
Okay, that makes sense.
It's about balancing speed and security, providing a responsive user experience without compromising the integrity of the system.
It's a tough balance to strike.
It is, but Tendermint does a good job.
All right, this all sounds great.
But before we wrap things up, I'm curious about something.
Okay, shoot.
We've talked a lot about the technical stuff, but what about the bigger picture?
Okay.
How might a system like Tendermint impact traditional institutions and social contracts?
Wow. Okay, so now we're getting philosophical.
A little bit.
That's a big question.
That's a question that really takes us beyond the tech itself.
Right. It's
into the realm of societal impact.
Asking how the printing press changed things.
Yeah.
The internet, like.
Exactly.
Huge fundamental shifts.
And if we connect this back to Tendermint,
Yeah.
These systems have the potential to disrupt
Okay.
how we think about trust, governance, even the role of intermediaries.
So give me an example. Like,
okay, imagine a world
yeah.
where contracts are automatically enforced. They code, right?
Interesting.
Where voting systems are immune to tampering, and financial transactions happen without banks.
Wow. It's like we're stepping into a sci-fi novel.
It feels that way.
But it also feels like those possibilities are very closer and closer.
They are, and that's why understanding these technologies is so important.
Right, because
they're not just abstract concepts.
It's not just
that they have the potential to reshape society.
Yeah, it's not just about geeking out over the technical details.
Yeah, it's about reckoning.
It's about understanding those broader implications.
These systems could change
exactly
how we live and work and interact with each other.
But of course, we need to be mindful of the challenges too.
Right. It's not more magic bullet.
Sunshine and rainbows, yeah.
So what are some of the hurdles?
What do we need to watch out for?
Well, scalability is a big one as these systems grow and handle more and more transactions.
Right.
Maintaining performance and efficiency gets harder.
So it's like trying to choreograph a dance.
Right.
With millions of participants.
Yeah, it takes a lot of coordination.
Yeah, exactly.
Voice chaos.
And then there are those questions of governance, right?
Yeah,
and regulation, like who gets to decide the rules
That's a big one.
of these systems?
Right, how do we ensure fairness?
How do we prevent abuse?
Exactly. It's like establishing the rules of the dance floor.
Right, who leads, who follows.
Exactly.
What happens if someone steps on someone's toes?
It's a good analogy.
But these are big questions that go beyond the technology itself.
They do, and these questions require careful consideration, collaboration between technologists, policymakers, and the broader community.
Right, so it's a group effort.
It is.
To figure all this out.
It's a conversation that needs to happen.
So it's not just about building the tech.
No.
It's about creating a whole ecosystem around it.
With rules, norms, safeguards.
Right, exactly.
To make sure these tools are used responsibly.
Responsibly, ethically.
Exactly.
Wow, this has been a really thought-provoking deep dive.
Yeah.
We've gone from the technical details of Tendermint to thinking about its potential impact on society.
Absolutely. It's fascinating stuff.
As a whole.
So
it's really impressive to see how this thesis from 2016 is still so relevant today.
It really is. It's a testament to Buchman's vision.
Absolutely. So if any of this has piqued your interest, we encourage you to check out the full thesis.
Yeah, it's worth a read.
For yourself, and keep exploring the world of blockchain and all this stuff.
Keep learning.
Because who knows, you might be the one to build the next groundbreaking application.
You never know.
So until next time, happy diving, everyone.
Happy diving.